So in this video, we're going to discuss how do you use compound interest formulas, when do you use which one, and how do you use your technology in order to process or make calculations using your compound interest formulas. So the first thing you need to know is that there are really two main formulas, okay? And we are going to talk about both of them and when to use them. The first one, we're going to go with the easy one first, okay? The first one is what formula do you use when interest is compounded continuously? This is the easier of the two formulas. It is A is equal to capital P e to the RT. Okay, now the key here is to remember that you only use this formula when you see the word continuously. If you can't find that word, don't use it, okay? If you can't find that word, you gotta default to the other formula, okay? The other formula is used when you are compounding interest n times per year. Fantastic. Well, we're gonna use this formula then. A is equal to P times 1 plus R divided by N raised to the NT power. Okay, fantastic. Now, formulas are great, but if you don't know what goes where, or what those things mean, we have a problem. Okay, so we're going to define what are those things. A, that capital A stands for accumulated value. How much accumulates in our bank account after a certain amount of time? Hopefully we see, if we leave it alone and don't spend it, that our money is growing, that it is gaining value. So this is what our A stands for. P, this stands for principal. Okay, often we can think about this as our initial deposit. How much did we put in the bank? Okay, N. N is the number of times per year we compound the interest. That means how often is the bank going to pay you? Okay, and let's talk about that just a little bit further. If your interest is compounded quarterly, how many times per year does that mean? So quarterly would be, how many quarters are there in a dollar? Quarterly, N would equal 4. Okay, what about if I said we are interested in compounding annually? What does that mean? That means once per year, or N equals 1. What if I said, I'm interested in compounding my interest weekly? Well, how many times per year is that? Well, how many weeks are there in a year? That would be N is equal to 52. How about daily? Right? How about daily? Well, in that case, N would equal 365. Okay, so that takes care of our N. R talks about our interest rate. Okay, and we always write this as a pure decimal. Okay, so I'm going to come down here and say, if I am talking about interest that's 4.75%, R would equal 0.0475. Okay, so you always have to make that conversion from the percent form to the pure decimal form. And last, T is going to be time. Most often in these cases, time is represented in years. Okay, so now let's look at a problem. Suppose you've got $12,000 to invest. I have $12,000 to invest. I want to make the most money possible. Which investment is going to yield the greatest return? And I'm thinking 3 years is what I'm going to invest it for. 7% compounded monthly. So this is we're going to call this account 1, or 6.85% compounded continuously. I'm going to call this one account 2. So I need to make this calculation, and then I need to compare the two and decide, well, which one is going to give me the most money. Okay, so let's look at account 1. First, determine which formula do I want to use. Compounded monthly. I don't see the keyword of continuously, which means I'm going to have to come up and use this formula. Okay, so A is what I am solving for. How much is going to accumulate in my account? A. A is equal to P, our principal, our initial deposit, $12,000, times 1 plus, what is R over N? Well, first determine R, of course. R is 7%, but I need to take that percentage and turn it into decimal. So 0.07 divided by N, the number of times per year. And if we're compounding monthly, how many months in a year? Well, that would be 12, of course. And then we're going to take our our N is going to come up here as well. These two always match. And then times T. How many years? I've got 3. Okay. So now I'm going to use my handy dandy calculator. This is account number 1, right? And I am going to crunch this number. Right, so this is kind of what it needs to look like. The biggest mistake I see students make is not keeping the exponent in parentheses. Notice that that exponent has 2 things being multiplied together. Well, if it's got more than one thing, we need to keep it in a set of parentheses. So it looks like we are looking at about $14,795.11. Now, when we're talking about money, we're always going to use 2 decimal places. Why is that? I don't know that I carry around fractions of pennies with me, okay? So always dollars and cents. So now let's look at account 2. Account 2, 6.85% compounded continuously. Oh, we hit the jackpot because we can use the easier formula. A is equal to P, which is $12,000, times E raised to the rate. In this case, our rate is different. 6.85% is going to be 0.0685 times T, which is still 3 years. Okay. So now remember that E is not a variable. E is a number on our calculator. And so we're going to go ahead and crunch this one. 12,000. Use that E to the X button, which is second ln. And then we're going to do 0.0685. Notice that it opened up a set of parentheses for you for that exponent. Okay, so it should look like this. And let's see, it looks like we end up with $14,737.67. So, now let's go back and answer the question. Which investment yields the greater return over 3 years? And I compare the 2 amounts. This one is the better one, so I'm going to say account 1 is the winner. That's where I'm going to put my money when it's time for me to invest. All right, take care, guys. See you next time.